So the next concept is relative strength tables. And in order to do relative strength tables, we need to have an understanding of the fact that redox reactions can be either spontaneous or non-spontaneous. In other words, if I take an oxidizing agent and a reducing agent and I mix it together, will I observe a reaction that happens on its own? Or if I take an oxidizing agent and a reducing agent and I mix them together, do I see no reaction? And so spontaneous means that the reaction occurs on its own, by itself. A non-spontaneous reaction means that it won't occur on its own. So to identify whether a reaction, a redox reaction, is spontaneous or not, we have this right-hand, left-hand rule that we have to follow in our reduction half reaction table. So if you turn to page 7 in your data booklet, right here, we've got our reduction half reaction table. And the rule is that if my oxidizing agent is above my reducing agent on the table, then that's going to give for a spontaneous reaction. And this makes sense because I know that my strongest oxidizing agents are over here in the top left-hand corner of the booklet, and my strongest reducing agents are down here in the bottom right-hand corner. And so if I take a really strong oxidizing agent, something that loves to gain electrons, and I mix it with something that loves to lose electrons, that reaction is going to occur really quickly. And so if I move down the chart a little bit this way and up the chart a little bit this way, then that reaction will still be spontaneous, but not as spontaneous as these ones. For the purposes of this class, you don't need to guess or predict how spontaneous something will be. You just need to identify whether it will be spontaneous or not spontaneous. So that's how we know whether something is spontaneous, is if I see my fingers look like this. My oxidizing agent is above my reducing agent. For a non-spontaneous reaction, if my oxidizing agent is below my reducing agent, then that yields a non-spontaneous reaction. So if my fingers look like that. So here's an example over here on the board. If you look at copper solid on the chart here, you'll find that copper solid is right, and I'm looking at this upside down. Right here. So I stick what looks to be to you, my right finger on my reducing agent. There's copper solid. And I find silver ions, which is right there, and you can see that my left finger is above my right finger. So my oxidizing agent is above my reducing agent. This makes for a spontaneous reaction. And sometimes you'll see spontaneous written above the arrow like that, so that it tells you, hey, that's a spontaneous reaction, or you can just look in the book and find out. This reaction here, if you look at tin 4 positive, which is right here, and I find I minus, which is right here, you can see that my reducing agent is above my oxidizing agent on the chart. And so this makes for a non-spontaneous reaction. Sometimes you'll see written above the arrow, no reaction, or non-spontaneous. If you see something above the arrow like that, don't be surprised. That is a non-spontaneous reaction based on this rule. So what we're going to jump into next is how we can use spontaneity to determine strengths of oxidizing agents and reducing agents. So here's what we call a relative strength table. It shows us reactions that occur between different substances as being either spontaneous or not spontaneous. And so we can use reduction half reaction tables to help us fill these charts out in letting us know whether a substance will react spontaneously or not spontaneously with another substance. So the first thing that you need to understand is that you have to identify whether the oxidizing agents or the reducing agents are written across the top of the table and down the side. And it's not going to be consistent from chart to chart. Sometimes the oxidizing agents will be on the top, sometimes the oxidizing agents will be on the side. You have to just quickly identify and look, okay, if copper 2 positive turns into copper solid, then I know that copper 2 positive has to gain 2 electrons to do that. So this is an oxidizing agent. And you look at all of these, and that's the case. They will always put all the oxidizing agents all together and all the reducing agents all together. Otherwise, these charts don't work. So my oxidizing agents are across the top and my reducing agents are down the side. Now, what I know is that copper won't react with itself. And this is kind of like if you've ever seen a volleyball tournament, a round robin tournament of any kind, and where teams are playing against other teams. You can't play against yourself. So the middle part of that is always crossed out. So it is with these reactions here. Copper doesn't react with itself. Zinc doesn't react with itself. Lead and silver, same thing. If I look on this chart now and identify which substances will react spontaneously with other substances, I can start to put X's and check marks into these boxes. So you can pause the video right now and go ahead and do that using the left-hand, right-hand rule and your reduction half reaction table, and fill in the boxes here as they relate to whether the reaction is spontaneous or not. So here's the answers that you should have got. What you'll notice is that the strongest oxidizing agent is going to have the most check marks. So if you look at silver on the chart, you probably noticed that silver is the highest one on the chart, making it, of the group of 4 here, the strongest oxidizing agent. And so it is going to spontaneously react with all of these reducing agents because they're all below on the other side of the chart. Conversely, you can see what is my weakest oxidizing agent, and that is zinc. And it's got 4 X's. Doesn't react spontaneously with any of these reducing agents. If you look at the reducing agents going across the table like this, you'll notice that my strongest reducing agent has the most check marks, 3. And my weakest reducing agent, which is silver solid, has no check marks, all X's. And so we can fill these charts in quite quickly just by using this reduction half reaction table, and then we can be asked questions about which one is the strongest oxidizing agent of the group, which one is the strongest reducing agent. You can even be asked to rank the oxidizing agents from strongest to weakest, or also rank the reducing agents from strongest to weakest using the information in this chart. So now what you can see sometimes is that instead of asking you to build these charts, sometimes questions will give you the charts. And so it's kind of working backwards, where before we made these charts using a reduction half reaction table. Sometimes what they'll do is they'll give you a chart and then ask you to build your own reduction half reaction table, where the oxidizing agents, the strongest ones, are found in the top left-hand corner, and the strongest reducing agents are found in the bottom right-hand corner. And again, we do this using that left-hand, right-hand rule, where if a spontaneous reaction is occurring, then the oxidizing agent is above the reducing agent, and we can go ahead and build these tables quite easily using that rule. But that's the key, is you have to use the left-hand, right-hand rule in order to build these tables appropriately. So if a question gives me this and it asks me what is my reduction half reaction table, then I have to look at the spontaneity of these reactions. First of all, I can see here that cadmium solid is my strongest reducing agent. I know it's a reducing agent because this turning into this is going to be reduced. So this would be my oxidizing agents up here. These would be my reducing agents down the side. And because this is my strongest reducing agent, I know that that then is going to go down here at the bottom, CD solid. I also know that my strongest oxidizing agent is AB3 positive. And so this one is going to go up here in the top left-hand corner. And I can write this as a reduction half reaction. Just like that. I know that BC positive is just below that. It's got one check mark, so I can put that one just below. And I'm only going to add 1 electron to that because its charge is only 1 positive, and I know it's neutral over here. And then my last one is obviously CD2 positive, which goes below that. Like that. So here again, I can double check to make sure that the check marks correspond with the spontaneity using this reduction half reaction table, and I can make sure that that fits. If I find a discrepancy, then I know I've made a mistake somewhere. If I come over to this one right here, what you'll notice is that my oxidizing agents now are actually on the side, and my reducing agents are along the top. And again, the way that I can figure this out is if I look at D2, for example, when it turns into D minus, then it's gaining electrons to do that. So I know that the D2 is gaining electrons, therefore it's the oxidizing agent. So these are oxidizing agents, those are reducing agents. That then tells me that my oxidizing agents need to go on the left side of my chart and my reducing agents need to go on my right side. And if I look at the chart here, you can see that E2 is my strongest oxidizing agent. So I'm going to write that one first. These should all be gases. My next strongest oxidizing agent is D2. And P2 goes at the bottom. And again, you can use your left-hand, right-hand rule to check whether this reduction half reaction table fits the spontaneity information that I have up here in the chart that was provided. So the last way that you can be asked to do relative strength tables is if they give you reactions like this and then they identify for you in this way whether the reaction is spontaneous or not spontaneous. And then they'll ask you to write out a reduction half reaction table, again organized like the one in your data booklet or like the ones we did in the previous video, where the oxidizing agent, the strongest one is at the top left-hand corner and the strongest reducing agents are in the bottom right-hand corner. And then they'll ask you questions like, what's the strongest oxidizing agent, or rank the oxidizing agents from strongest to weakest. And you can do that easiest if you build the reduction half reaction table. So let's take a look at the information that we've got here, and then let's build our reduction half reaction table on the side. So right here I've got CD solid reacting with H+. Now, in terms of the coefficients here, you don't need to worry about the coefficients. When you're writing your reduction half reactions over here on this side, only worry about writing them out and having coefficients if you need to balance them based on the number of electrons. And I'll show you what that looks like. But right here, all you have to worry about is what is my oxidizing agent, what is my reducing agent? And in this reaction, I can see that H+ turned into H2, which means that it gained electrons to do that. So this is my oxidizing agent, and this then is my reducing agent. So I know that my H+ is going to go on this side of my chart, and I can write the half reaction for that like this. And I know that when it reacts with CD solid, this is a spontaneous reaction, which means CD solid has to go over here. And so then I can write my reduction half reaction for that. I know that CD as an ion, as an oxidizing agent, is 2 positive, and so I'm going to gain 2 electrons to become CD solid. So then if I can double check my spontaneity rule, I've got H+ reacting with CD solid. That's a spontaneous reaction. Left finger over right, spontaneous. That matches, so I'm good so far. Then I go to the next reaction and I can see that Hg solid, which is also a reducing agent, reacts non-spontaneously with H+. So that means that this has to go above. So my Hg solid is going to go there. And again, I know that my other one for this is Hg2 positive. That's going to gain 2 electrons to become Hg solid. So you can see how this chart is starting to form. Over here, again, another spontaneous reaction. This time Cd2 positive is my oxidizing agent, and it's reacting with Be solid, my reducing agent. So I know that because it's spontaneous, BE solid has to go below so that it follows the left-hand, right-hand rule. That means that this is BE 2 positive aqueous plus 2 electrons makes BE solid. Then finally the last one here, again BE solid is my reducing agent and it reacts non-spontaneously with Ca2 positive, which means Ca2 positive needs to be below. So I'm going to write it below like this. And using this information right here, I can now have made my reduction half reaction table over there. And then I can answer a variety of questions about oxidizing agents and strength of those oxidizing agents or reducing agents and rank them. And it becomes quite easy because I know right here are my strongest oxidizing agents and they get weaker as I move down the chart. And I know that these are my strongest reducing agents and they get weaker as I move up the chart on that side. Also, something to point out as well is that when you're doing these reactions, or when you see sometimes these reactions, they won't always be written exactly like this. So another way that you could see it is they might take out the spontaneous and non-spontaneous, and instead, when it's not spontaneous, they won't write in the products. They'll just say no reaction. So if you see products, then that means it's spontaneous, and if you don't see products and it just says no reaction, then you know it's non-spontaneous. And so you can see that as a small adjustment for these types of questions. So I point that out so that you won't be confused.